Here we go, checking out Learning Target 1, which is all about different types of forces. We focus mostly on contact forces in our notes, thinking about ways forces occur by objects coming in contact with each other. So we've got some images here with some arrows showing off where those contact forces are happening. So here we see a skier going downhill. We've got the arrow going opposite of the skier's direction, right at the spot where the skis are in contact with the snow. This would, of course, be looking at a friction type of force. So friction is when we have an object moving over a surface. It's kind of a key part of it, moving over a surface and resisting motion, so slowing it down. So different surfaces relay different friction to different objects. So obviously snow would be low friction, grass would be a higher friction. Here we have the arrow going downward from this person doing a skydive. We know that downward arrow is the force of gravity, right? Pulling objects to earth. We're going to see this on every single object. So when you're asked to think about forces, hopefully your mind goes there first. Gravity is always going to be there. This guy here, this is magnetics. Okay, we're not really thinking much about that magnetic force. This one is not a contact force, just like gravity. There has to be, these forces work without specific contact. Here we see the arrow from this dude pushing these boxes. So him putting a force onto that cart and those boxes, that would be an applied force, just a general push or pull acting on the object. Here, now we've got a little different situation. We have an arrow upward from this book sitting at rest on a table. So the table is exerting a support force to the book. This is our, of course, normal force that we're going to see for any object on a stable surface. And that object can be not moving or moving. It really doesn't matter as long as it's on and being supported by that stable surface. Normal still exists. So my skier up here would still have a normal force acting on it. Okay? Here we've got the tug of war example. So the arrow going both ways from that rope being pulled tight. That one is going to be tension. Make sure you have something about when the rope or the string or the cable is tight. So it's not just the rope laying on the ground has tension, but when it's pulled tight. We also talked about examples like the tire swing. When it's hanging, that tension force is going to be upward then as that rope is pulled tight. Here we see another upward force. This is in the parachute right here, right? That object is falling, so we know gravity is the downward force. The upward force is that air resistance. Right? Air resistance are those air molecules, kind of like friction, slowing down that falling object. And finally here, with the jack-in-the-box, hopefully this gives you a little clue. This one here is spring force. Again, make sure you have that word spring in your definition. Saw a lot of them that just said objects compressed or stretched out, but it should be when a spring is compressed or stretched. So knowing those examples and definitions, we should be able then to plug them in here on our learning targets. So definitions and examples. I do appreciate those of you that had your definitions and examples color-coded a little bit, so maybe highlighted one so they kind of stood out and were differentiated. And it's always good to have maybe more than one example so you don't just kind of get stuck on one thing. So when we're thinking about seeing these in real life, we want to be able to label them out. So here we've got pushing a box. So of our choices up here, Hopefully one kind of stands out. We have a similar picture. That is the applied force of the guy pushing onto the box. At the exact same instant, we have a frictional force going in the opposite direction from the surface and the box. And we know that that arrow is going to be a little bit smaller than the applied force since the box is actually in motion. This object still is being impacted by gravity and still being impacted by a normal force. And it's important to remember that those two forces are going to be equal or balanced because this object has no up or down motion. But overall, we would say this scenario is unbalanced, right, as the object is moving across the floor. Here we've got a couch potato, right? Couch potato. It's not moving. It's at rest. Again, when I'm thinking about forces, it's definitely going to have gravity there. And the second force, of course, will be normal, acting on the object upwards. Again, those are going to be equal, making this a balanced force. Okay, I would not put on friction or applied because there's no objects putting that push or pull on the couch or the potato. I could also point out normal and gravity for both the book there and the couch on the floor. Again, every object has those interactions all the time. So again, on your learning target, you're making sure you have definition and example. You know, multiple would be great, just to reiterate your practice.